In 1871, Charles Darwin wrote a letter to his close friend, Joseph Dalton Hooker, in which he outlined his ideas for the origin of life by describing a warm little pond. This term may or may not be familiar to you, but it is familiar to the scientific community, as warm little pond has been widely used to introduce the ideal environment for the origin of biological life. It is often considered the accepted explanation for how the first life forms were generated. In reality, understanding the exact way these complex biological systems came to be is still in progress, and sometimes you need to look outside the box, or in this case, the pond. My research looks at amino acids, which are the building blocks of proteins and essential for life. The bonding of one amino acid to another is called a peptide bond and is the basic mechanism for the production of a protein molecule. But many amino acids do not bond readily inside liquid solutions containing early Earth simulations. But what if we look at these reactions in something else? Atmospheric aerosols are defined as small, solid, or liquid suspensions in air globally distributed in the atmosphere of Earth, aka the tiny droplets in the air all around us. Aerosols would have formed naturally on early Earth and contained chemical elements that underwent reactions. However, these reactions are different than what you might expect in a simple beaker, as they are faster and more optimal. For me, this opens the door to a whole new world of possibility beyond Darwin's pond, such as peptide bonds of amino acids. So, we want to know if amino acids can form peptide bonds inside atmospheric aerosols. But how can we look at a chemical reaction in something so small? Optical trapping is a method developed for single particle levitation and is what I use to monitor the chemical transformations inside aerosol droplets. About the size of my palm, our optical trap uses 2 light beams that levitate a droplet and allows us to record the chemistry in real time. We can look at the individual chemical bonds that are breaking and forming, specifically the peptide bonds of amino acids. My research looks at underdeveloped ideas that may not align with what is generally accepted. The origin of life, and therefore the origin of everyone in this room, is one of humanity's greatest unsolved mysteries. I believe the only way to truly solve that mystery is to take a step outside the warm little pond and look up at its atmosphere.